Okay, today we are going to talk about index numbers. You still there?
Yeah, I'm
Hello?
here.
Okay, so we are going to talk about index numbers. The index numbers are very simple to understand. Sometimes we, have some more complex ways of doing an index, but index number is simply a measure of the relative value. Okay, it's a method of comparative value. You can say relative values. I'm going to pull up share my screen so that you see what I mean. Okay, so like I said, and you have some examples. Are you seeing my screen? Hello?
Yes, yeah.
All right, please respond. Okay, the measure of relative value. Okay, for example, a price index. You may have heard about, have you heard about the consumer price index?
I think I heard before, but I'm not sure.
Okay, well, consumer price index is reported every day in the news. That is how you measure inflation. Okay, I'm sure you have heard about inflation. So consumer price index is a measure of comparative prices. For example, if an apple um, cost 50 cents last year and cost $1.50 this year, and let's say Apple is the only thing you consume, then the consumer price index between last year and this year will be $1.50 over 50, which is 3. So the measure of how prices have changed over time. And then producer price index is again refers to the comparative prices of goods that are used in production. Okay, import price index, for example, is a measure of the prices of imported goods. So which is not all the time, but then price index is not the only index that is calculated. You have quantity indexes, which is a relative measure of the quantity of goods produced, and a value index. For example, um, a measure of say, um, the salary, okay, or the value of certain things. Uh, if your salary was $100 last year, and this year your salary is $125, then the 125 will be divided by the 100, and you get 1.25. If your salary was 125 last year, next year is 130, then the 130 will be divided by 125. And so you reduce the price for each time to some comparative level with another time. And the original measure or the original value, is called the base. All right, so let's see what we have. So we have something like a simple index. Okay, uh, the homework assignment that you have is actually based on a simple index. And I'm going to pull up that assignment, and we're going to look at a simple value and then say what is the index of one value compared to another one. All right. Okay. So have a very simple index. Just compare two numbers. Okay. Let's see if we are going to um, get an example of a simple index and use it. All right. Try to get an example of a simple index. Okay. I have some simple index here. All right. And I'm going to pull that simple index up. Okay. I'm going to put a simple index up and then show you. So this is an example of simple index. Okay. All right. So this is an example of a simple index. Can you see the numbers? You can. Okay, let's see. Okay. Now, I'm trying to use this very simple example. You have a team. You have different teams: Arizona, Atlanta, Baltimore, Red Sox, Chicago, White Sox. Which again, I'm trying to illustrate that an index does not have to be about money or about prices. Okay. So, for example, you look at the index of capacity. Okay. You see, we have capacity here. Can you see my screen?
Yes.
All right. Okay. What is the capacity for Arizona?
48,633.
Okay, for the A633, okay? And the capacity for Atlanta is 49,586. Now, we want to compare Arizona, Atlanta, Baltimore, Red Sox, Chicago, and White Sox. We want to compare them to Arizona. And so Arizona is the base. So we take Arizona as the base. And so when we compare capacity, we divide every value every other value here by Arizona's value. So we take 49,586 and we divide it by 48,633. What do we have? What we have is 1.02. So we also divide Arizona by itself and we get 1.00. And we divide Arizona by Atlanta by Arizona, we get 1.02. We divide Baltimore by Arizona, and we get 0.95. So what it is simply saying is, what is the capacity of these stadiums compared to Arizona? So Atlanta is by 1.02 or 102% of Arizona, while Baltimore is 95% of Arizona, and Red Sox is 77% of Arizona. That's what we're saying. We look at the number of wins, okay? We compare everybody to Arizona, and so you see Arizona has 1, and the other ones are different from 1, unless their values are exactly equal to Arizona. So this is a very simple index. And the homework assignment that I gave you is pretty much like this. And we're going to get to it in a minute. All right? An example of a simple index. And so now, again, the textbook, does this by comparing the population of Colombia with the population of Ontario and multiplying by 100%. So that is 34.4%. Okay, these are other examples of a simple index. And here they're comparing airport passengers to Houston. And Houston is at the bottom here. So they divide the other ones against Houston and get comparative values. As I said, an index is just an example of comparative values. Okay. Here's another example. We can compare the steel production of other countries to China, and so we divide 197 over 197 to, let's see, so here I'm going to calculate some index. All right. So here I'm going to say 197 over 197 is equal to 1.00. All right. And here I'm going to take 144 to 197. And what does it give you? Can you give me the number? What's 144 over 197? Hello?
73.
77. Okay. Point 0.73 to 0.73 or 73%. Okay. Or 100%. Okay. All right. So this one is 103 over.
Divided by 1.7.
What do you say?
Give me 0.
It's 0.5228. Okay. 0.5228, which is 52.28%. All right. So all right. So you can do the same for the other ones. Okay. Which is 0.3959, 78 to 197 equal to 0.3959 or 39.59%. All right. So let's just do the last one, 2. Okay. 52 to 197 equals to 0.26, 0.2639, which is equal to 26.39%. All right. So essentially, this is what is called a simple index. Okay. And we're comparing the steel, the production of steel in other countries to the production of steel in China. We're comparing how many millions of tons of steel produced in these other countries to the quantity of steel in billions of tons produced in China. So we use China as the base, and so it's 100%. Now you can use any country as the base. You can use any reference as your base. It does not have to be the biggest one. It could be, you could use USA as the base. And these numbers on the right-hand side will be different. All right, so that is an example of a simple index. And it could be about quantities, it could be about prices, it could be about values. All right. Now, we can have what we call an aggregate index, okay? We can have what we call an aggregate index. Now, an aggregate index is where we are combining several items. And we are trying to compare the cost of the aggregate of items in 2 time periods. We want to compare the cost of this aggregate of items in 2 time periods. For example, we wear clothing, or let's use something that we can easily make reference to quantity. Okay, you eat 5 pounds of chicken a week, and you eat 2 pounds of beef in a week, and you eat 3 pounds of turkey, and so forth and so on. Okay, so now the question is, last year you bought 5 pounds of beef at $2 a pound, and this year you buy the same 5 pounds of beef at $2.20 a pound. Then you ate 10 pounds of chicken at $1 a pound, and you ate 15 pounds of turkey at $1.25 a pound. Now you compare the price last year with the price this year. So this is what we call an aggregate index. You're gonna say to yourself, okay, last year I consumed 10 pounds of beef at $2 a pound, that's $20. And then 10 pounds of chicken at $1 a pound, that is $10. So you spend $30. And then you consume 10 pounds of turkey at 50 cents a pound, that is $5. So you look at that, you have $35 that you spend. Now, if you spend different amounts of money this year, you might end up spending $40 for the same 3 items if you consume exactly the same quantities. So the question is, in order to consume what you consumed last year, would it cost you more or would it cost you less? All right, but you represent that difference in cost using an index number. So let's see how we do that. All right. I will pull up an example. All right. The one that is given by your book. And we're going to use that. So another example. A simple aggregate index. Okay. All right. Now, what you have here is that you take, say, the price of bread. Okay, this is the price of bread. The price of bread was $1.04 for a loaf of bread. In 2003, in 2013, it was $1.35. Now we are not looking at quantities yet. We're just looking at basic price. Okay. We look at eggs, it's $1.18 a box, or a dozen, and in 2013 is $1.93. Okay. And so milk is $2.69 and $3.53 in 2013. So you take each one and calculate the index. For example, the index for bread is $1.35 divided by $1.04, which gives you what you have there. Okay, gives you 1.298, 1.35 divided by 1.04 gives you 1.298. Okay. Now, what do? What you do now is you add up all the prices for 2003, which gives you $4.91. You add up all the prices for 2013, which gives you $6.81. So now, in order to get the index of relative prices, you divide $6.81 by $4.91. And so what do you get? You don't get $4.26. The relative price here will be 6.81 divided by 4.91. And what does that give you? Okay. Gives you 1.386. 1.386. So what does that tell you? It tells you that between 2003 and 2013, prices increased by 38%. And I'm going to make that very clear. Okay. And I just want to make sure that we follow what's going on here. So relative prices will be $6.81 divided by $4.91, which is 1.386, or an increase of 38.6%. So that is what is called a simple aggregate index. You just compare the prices, but you do not include quantity. So now there are other kinds of indexes. One is the weighted aggregate index, that's called last payers index. And the other is, this is an example of last payers index. And the other is called the PASH index. Okay, it's another kind of weighted aggregate index. So let's see if we can pull up an example. There's an example here, and I'm going to also pull up another one. This is the cash index. This is the last payers index. Okay. So now, how do you determine the weights? Okay, you put weights on the prices. Okay, you put weights on the prices. So let's look at how we determine the weights. The way you determine the weights is you look at the price that you paid in the next period. For example, we are looking here at 2003 and 2013. Okay, so we calculate the price. We take the price of 2013, all right? The quantity here is $1. The price here is $1.42. And then the quantity is 50. But we take the price here of $1.42. Okay, I'm going to illustrate that for you. All right. We take the price of $1.42 and multiply it by 50 to get 71.1. Okay, let's see if we can do that. And then we take the price of $1.93 and multiply it by 26 to get 50.26. Okay, and then this is one calculation. And then we divide it by taking the price at the base year. The base year is 2003. We take the price and multiply by the quantity. Okay, and so once we get the two multiplications, here we get 692, we divide it by 493. And so the index for the two periods is 140.28. So we are saying that prices increased by 40.28%, because the price in 2013 for this aggregate of goods is 140% of the base year price, because the base year is 2003. Okay. That's an example of what we call the last payers index. Now, when you look at the way indexes are calculated, the choice is yours, or the choice is a decision that is made. You can use the last payers index, or you can use the PASH index. It's really a choice, and it depends on your point of view. The PASH index is slightly different, but it comes to just a matter of choice. And I'm going to put up a couple of examples so that you can see other examples of the use of indices. All right, now I'm going to look at your homework assignment, and then I will illustrate how you what do you call it? How you do the homework assignment that I gave you, because I gave you a rather simple assignment, which was to calculate a simple index. I'm going to stop this share and pull up the homework assignment so that you would know how to do the homework assignment. Okay, so let's go through that illustration again. Okay. Your homework assignment, we did it very simply. We're going to do it again. Okay, so we're gonna do the PPI index base 1950. Okay, so we divide every PPI here by the 1950, so that's in G5. So we go equals G5 over $G $5. And we make that into a percentage and just drag down the screen. Okay, we can do that also for the CPI base 1950. All right, so when I say equals $H $5 equals H5 over $H $5. All right, we make that into a percentage and we drag it down. All right. Okay. So that is how we do a simple index. And so the assignment that we have is a simple index. Okay. So do you have any questions? Hello? Do you have any questions?
Actually,
Hello? I can hear you. Hello? Hello? Are you still there? Because I cannot hear what you're saying.
yeah, can you hear me?
Okay, I can hear you now.
So I have a question, but not for this assignment, and I have a question for module 10 assignments.
Okay, go ahead and ask your question for module 10 assignment.
Okay, just I am confused about this prediction of the price of houses.
Let's see what your question is about. Okay, so we talked about that last during the last let's see. Okay, so what were you confused about? So we can clarify.
So it says basement is 0, but where I have to put the 0 in the brackets, or I mean,
now it said basement is 0. Is that correct?
gas is 0, yeah.
So when you are
But
doing,
I see numbers here.
oh no. Okay, I see what your problem is. Let me pull up the assignment, and then I'm going to illustrate to you what the issue is. Okay, I'm going to pull up the model. Okay, and it was in the last model number 2. Okay. Okay, let's see how we're going to do that illustration. Okay, are you seeing my screen? Hello?
Yes, yeah.
Okay. You see where you have, you said that basement is 0. Is that correct?
Yeah.
Okay. Now, also, Eastville is also 0. See, like here where you have a number for Apple, but if you had Eastville, this value here will be a 0. So that means when you get to like this basement, is that correct?
Yeah.
Good. So basement is not 0. Basement is 1 if the house has a basement. And it is 0 if the house has no basement. So if you're asked to predict the price of a house that has no basement, when you come to basement, you put 0.
Yeah.
You get the idea?
Yeah.
Okay. Let's see what the question was asking you. It says, where do you have that basement question? Using model number 2, would you predict the price of a house that is 18 years old, it has a basement? If it has a basement, that means basement is 1. So when you come in here,
in my question, it says no basement.
Where? Which one?
Here, this is the same question. Using the result of model 2, what would you predict to be the price of a house that is 15 years old,
Okay.
no basement, in Eastville,
This
gas
one.
type heat?
Okay, that's number C. That's number
Yes,
C.
C.
Very good. So when you come here, when you use this model number 2, right? You come to basement. You see, I have a 0 here. See 0?
Yeah.
0 times that number will give you what?
0.
0.
Okay.
That's what it is.
Okay.
You get it now?
Yeah.
Okay. If the house is in Eastville, you see, if the house is in Apple, then 1 times Apple will give you that, will add 6,089 to the house. But if the house is in Eastville, then it will be 0 times this number, which is a 0.
Okay.
All right?
Yeah.
Okay. Any other questions?
Okay, I have a question for the same, but question number 1.
Okay.
So it says, are Eastville houses more expensive or less expensive than houses in Apple Valley? So what I'm going to use is the T.
Okay. So in that
And
case, you are testing the hypothesis. Okay.
Yes.
Okay, you're testing the hypothesis for the coefficient of Apple, right? Yeah. Okay. If you test the hypothesis, you have the T value and you compare it to the critical T. So if this, if the Apple is, what do you call it?
The apple is 3.465 and the Eastville is 3.491
Okay, where do you see that?
in the table.
Okay, let me see which table you're looking at.
Number one, question number one.
Okay. Okay, table number one. So you're using model number one. Apple here, but it doesn't.
Apple.
So if you're using model number two, Apple is 6089 and the t-value is 2.32. So essentially what you are simply saying is you test this hypothesis. If this hypothesis, remember you choose your own critical value. If you choose the level of significance and then the critical value is say 1.96, then you can say that the houses in Apple are likely to add 6,089 to the value. But it's asking you to compare the two. So what essentially you're doing there is a hypothesis test for two populations. That's a totally different question. So you use a different table here.
No, I'm using the table that is this table, independent sample test.
Yes,
of
that's what you are using. You're using independent sample test. And so you use the independent sample test to test if houses in Eastville are more expensive than houses in, so here you have the actual selling price of houses. You are comparing Apple Valley to Eastville. Is that correct?
Yeah, yeah.
So you use the standard deviation and what have you. If you have this independent sample test here, so here you see there's a difference in the price of houses. Okay, if you use this confidence interval, you can see the confidence interval shows positive, the lower and upper level of the upper value of the confidence interval. So you reject the null hypothesis of no difference, right? Okay. You reject the null hypothesis of no difference, which means you conclude that there is a difference because you're rejecting the null hypothesis that there is no difference. Okay. So Apple Valley houses are 104,000, right? And then Eastville houses are 87,000. So given this difference and your rejection of the hypothesis, then the Apple Valley houses are more expensive. You get it?
So we're gonna use this table, the mean. We're not gonna use the T.
You can use that, but that's going to take you to a long process. You already have the t-value given to you here, 3.465. So you use it and you compare it to a critical t-value.
Yeah.
You
but what I'm saying is that Apple Valley is related with the 3.465.
Oh, no,
and the
no,
is related with 3.59 when I did the.
No. Okay, I mean, I should have eliminated one of the t-values. Okay, the two t-values are the same. You can use one or the other.
Okay.
Okay, when you test a hypothesis, you can only have one t-value. So in that case, since this will lead you to reject the null hypothesis of no difference, then you are concluding that there is a difference because your null hypothesis is there is no difference. If you reject the null hypothesis, then you are saying there's a difference. And only one of these t-values you have to use. You don't have to use the two of them, no.
Okay.
All right?
Yeah.
Okay. Any other question?
No.
All right. So have a good night. I'm going to post this for the rest of the class and everybody will see it. All right?
Okay.
Okay. Good night.
Okay, good night.